All right, guys, welcome back to the lesson about some old hippie caught another hippie tripping on acid. I mean, Sokoto. I'm sorry. Welcome back to activity 22.2 about trigonometric ratios. I'm Coach Williams and Mr. Williams, and we're going to go over the answers for numbers 8 through 14, starting on page 310 on the PDF file. Okay, so question number 8. They give you a triangle and they ask you to find the sine, the cosine, and the tangent of the different angles. I'm going to run through those. This is exactly like the practice problems I gave you in the video prior. Okay, so hopefully you got this right. Let's just make sure. We're going to look at A first. If we're looking at A, that's going to make this our hypotenuse because it's the longest side, and that's going to make this our adjacent because the adjacent and hypotenuse are always going to make the angle that you're looking at. Okay, and that's going to make that the opposite down there. So definition of sine is going to be opposite over hypotenuse, or 8 over 17. Definition of cosine is adjacent over hypotenuse, so 15 over 17. And definition of tangent, opposite over adjacent, so 8 over 15. Hopefully that makes sense. Hopefully you did good. Now, we're going to remark our triangle because we're talking about our different angle now. We're going to look at C. So if I'm looking at this angle C, this is going to be my adjacent. This is still my hypotenuse. Hypotenuse never changes. But now this is going to be my opposite. They switch places. Okay? So the sine of C is going to be 15 over 17. The cosine is going to be 8 over 17. And the tangent is going to be 15 over 8. Reminder that the cosine is going to equal the sine. The sine is going to equal the cosine when you're looking at complements, when you're looking at angles that add to 90. And then the tangents are simply going to be flipped. So 8 over 15 versus 15 over 8. That's always going to be true. Okay? And that's exactly what they ask you about in the rest of question 8. Part B asks you, hey, what do you know about A and C? Well, A and C are complementary, meaning that they add to 90. Then it says, hey, what do you know about the sine of one versus the cosine of the other? They are equal or congruent. And then the last part says, how would you find or what other measurement would you know if they give you the sine of 68? And so what I showed here is that you would do the cosine of its complement, and its complement you could find by doing 90 minus 68. Okay, mathematically it's 22, so in reality we know the cosine of 22, and so the cosine of 22 would have to be 0.93. Hopefully that makes sense. All right, let's talk about number 9. Number 9 gives us a 30, 60, 90 triangle, which is a special right triangle. And they say, how would you know the reduced form of any 30, 60, 90 triangle? Remember, the special thing with 30, 60, 90 triangles is that this relationship always held true. Whatever this was double it. And so if we're putting this over this, you're always going to get x over 2x. That's what we have there. And then notice is our x are going to cancel out, and you're always going to get 1/2. Okay, so the sine of 30 is always going to be a half. It doesn't matter if it's that triangle you drew on your paper or the one in front of your school. If it's a 30, 60, 90 triangle, the sine of 30 is going to be 1/2. Number 10. Number 10 is very similar to D. On question 8, they give you sine of t. They want to know what else you could find, or sorry, they give you the cosine of s, but the cosine of s is going to be equal to sine of t. The reason I know it's s and t is because they tell us that r is the right angle. We could draw it just to make sure we're clear here. Here's our r, here's our s, here's our t. Okay, and remember, if we do cosine of s, this one over this one, it would be the same as sine of t, this one over this one. Okay. Number 11. Number 11 is another Pythagorean triple. These are not going to go away. I talked about that in the video last week. Pythagorean triples are whole numbers that work with the Pythagorean theorem. This length is going to be 12. So when they ask us for the cosine of b, cosine is, let's label our triangle real quick. Hypotenuse here. This is the adjacent because it makes the angle. And there's the opposite. Okay. Now, let me pause for a second because I've been going kind of quick. Let's be very clear. If SOHCAHTOA is still new to you, if trig ratios are still new to you, if you don't have them absolutely memorized, then every single question you do, you should be writing down, okay, so I'm going to do SOHCAHTOA on that problem. Okay, so they asked me for cosine, so I do this. Oh, look, I'm going to use it here. And so every problem you should be writing down. When you did number 8, you should have wrote and then if you have to, remind yourself what it is. Sine is the opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. You should be constantly reminding yourself of what that is and how that works. Okay? so that by the time you get to the test tomorrow morning, those of you that are watching on a Monday, we're testing on Tuesday morning, by the time you get to the test, this will be common knowledge. This will be very easy, okay? So cosine of b, just as a reminder, cosine of b is adjacent over hypotenuse, so 12 over 13. And tangent of b is opposite over hypotenuse, so 5 over 13. All right, number 12. Number 12, straight calculator problem. I got nothing for you there. Other than make sure your calculator's in degrees, whether it's Desmos or a TI-30 or a TI-80 or whatever calculator you have. Maybe you have a Casio. I know they sold 2 last year. So my suggestion is just type in straight calculator, make sure you're in degrees. Here your answer, sine of 48 is 0.74, tan of 65 is 2.14, cosine of 12 is 0.98, and sine of 90 is 1. Okay, those are again straight calculator problems. If you didn't get these answers, you were probably in radians, which is a no-no. We're not there yet. You should be in degrees. Make sure your calculator is set to degrees for number 12. Number 13. You'll notice my drawing looks different than yours. Why? Because yours has these big, ugly numbers. What do I mean by bigger than the numbers? I mean, they put 36 here, and they put 27 here, and they put 45 here. And I didn't write that because I know that's a 3, 4, 5. I know that's a 3, 4, 5 times 9. So when I write these fractions, they're going to reduce down to 3, 4, and 5. And you're going to see what I mean by that. Sine of x. So here I am at x. Here's my hypotenuse. Here's my opposite. Here's my adjacent. Opposite is this one over this one. So 36 over 45, which reduces to 4 over 5. Okay? And we're going to do the same for all of these. So cosine of x would be 3 over 5. Sine of y, so now we're going to go to y. We have to redo our markings here. We're going to go to y. This is going to be my adjacent, this is my hypotenuse, this is my opposite. So sine of y is going to be 3 over 5, just like the cosine of x. And the cosine of y is going to be just like the sine of x, it's going to be 4/5. And the tangents are going to be reciprocal. So if I'm at x, you know what, we've got our triangle labeled for y. Let's do y first. So y is opposite over adjacent, so 3 over 4. That means my x is just going to be the reciprocal of that, 4 over 3. Okay? Hopefully that makes sense for 13. Number 14, they had a really good idea. It's like, hey, do you agree with the statement? The statement is solid with the exception of the fact that feet cancel. If you have 5 feet divided by 5 feet, technically the units are going to go away. They're going to cancel, and so your answer would just be 1. So the tangent of that particular triangle is going to be 1. Hopefully you notice it's an isosceles right triangle or 45, 45, 90. As a hint, the tangent of 45 degrees is always going to be 1. Guys, hope it made sense, and I hope that works for you. Don't forget SOHCAHTOA, and good luck on your test.